Hello, today we're building Tesla's Death Ray. I have to take all that wire off of that big coil and transfer it to this little piece of pipe to make a long and narrow coil. First thing I did was drill 4 holes in the pipe. 2 on this end about 1 inch in and 2 on the other end about 1 inch in. So let's wind this puppy. I think that should be enough wire. Once again, we do things because they are hard, not easy. There you can see how I wrapped it through the 2 holes like that. Now we're just going to wind it like this. So there's my 5-foot narrow secondary coil all wound and finished. Alright, now it's time to put the top on. I'm going to take this wire, cut it about right there. I'm going to take this end and strip it. Come on, get to the 14. There's the 14. I'm going to take this, put a little eye on it. Big enough for the bolt. My bolt, I got a mixing bowl right here with a 1/4 inch hole in it. I got an 1.5 inch PVC pipe cap with a 1/4 inch hole in it. So I'm going to take this and stick the lock washer on it. Stick the bolt in there. Tighten this around the bolt. I don't know if you can see that. Tighten that around the bolt. Take the cap, slide this on like this. Come on, get on there. Put the washer on. Where's the other washer? Put this washer on here like this. Stick the nut on. Tighten it. There you go. Now we're going to take this, shove it down in there. Put the cap on the top of the coil. So right here I have all the parts I need to make it. There's all my wood for the base. I got my drill. I got some screws and a bunch of hardware down there. Right here I have my 2 10-inch by 15-inch pieces of plywood. I marked it so I know where to drill the holes, and I'm going to drill both pieces of wood at the same time so the holes are in the same place. I'm also going to drill holes in the ends of these dowel rods. Alright, I got all my holes drilled, and I'm going to attach the 4 dowel rods to the bottom of the base with these 2-inch screws. Now I'm going to take this bottom piece and attach it to the 2x4s with 4 screws. Alright, I got the base built, and now I'm going to drill holes for the capacitors. I'm going to mark a grid on there. I have my grid marked off, and I'm going to drill 9 1/2-inch holes into the wood. Here, 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 just like that. I have all my capacitors and the inductor in place. Now we're going to screw the top on. Alright, I finished the base. Now I'm mounting the long secondary coil to it. I put 3 1-inch L brackets on there like that. I drilled a hole right in the middle for that secondary grounding wire. Alright, I mounted the secondary coil like that. I put a little insulator on there like that. So now we're going to make the primary coil. I threw a quick 4 turns of wire around the insulator. There I have all my capacitors wired in parallel with some number 14 copper wire. So this is the first DC circuit that I'm going to test with this thing. I got my light switch. I got my primary coil and my secondary coil. Here's the capacitor bank, and here's the inductor. I charge up this capacitor bank here. I close the switch and quickly open it, causing an arc. Yeah, this light switch right here is going to be on the end of the 10-foot stick of pipe, so I'm not even anywhere near it. A high voltage, high current pulse surges through the primary coil, and it induces a higher voltage into the secondary coil. I have the capacitor bank also connected to ground down here. Here's the positive, here's the negative connected to ground. Here you can see it, capacitor bank connected to the secondary coil and ground. And the first piece of grounded material that this arc jumps to feels the full effect of the discharge from the capacitor bank. So you essentially get a very long, high-powered arc. Yeah, I might even try to get this so this inductor is connected to ground. Yeah, this is an old microwave oven transformer. And what I want to do is connect this side to ground and connect this to the negative side of the capacitor bank and then run it up to the secondary coil. So I could drive the primary coil with the low voltage winding of the microwave oven transformer, and the transformer will boost the voltage up through the high voltage winding. So I only won't just have the power coming from the capacitor bank, but I'll also have the stepped up power from this transformer. And since this high voltage winding is basically an iron core inductor, it's going to boost the voltage from the capacitor bank up even higher and give it even more of a kick. And whatever that secondary coil up there arcs to that's grounded is going to get quite a wallop from it. Unfortunately, I can't test this today, mainly because I need some more parts for it. And I can't run this thing in here like this. I mean, you see how high that is. Yeah, I have to take this outside for a test, just in case one of these capacitors explodes. Yeah, I can't have sparks, foil, and dielectric flying all over the room. This is one of the reasons why I like DC better than AC. Because you can put it into an inductor, it pushes through it, and the inductor holds the magnetic field together and it boosts up the DC voltage into a long arc. Yeah, I never liked messing with the frequency of AC. That's a good way to give yourself cancer. It's like those new DC to AC freight locomotives that they're turning out that use variable frequency AC to control the speeds of the motors. It's like, is that healthy for the engineer and the conductor to be sitting above them motors with that variable frequency AC going through it and that strong magnetic field? That's a very good way to get cancer. Yeah, I saw a picture of one of Tesla's death ray designs. What it looked like was an oval-shaped coil with what looked to be current transformers around it linked together like a chain. I mean, it looked like something that would make really, really high voltage. If you're not familiar with current transformers, these are for current metering purposes in high amperage areas. These are the only transformers that are required to be shorted out under load if they are not connected to anything. Yeah, you do not want to have an open circuit with these things, and I'll tell you why. This is a current transformer with a 1000 to 5 amp ratio, which means if you have 600 volts, 1000 amps going through here, it's going to step that current down to 5 amps for safety, for metering purposes. And when you step down current, voltage goes up proportionally. If that circuit opened up under load, it's going to take that 600 volts and step it up about 200 times. So instead of 600 volts, you're going to have 120,000 volts coming out of that output. So if a current transformer is ever under load, you always leave this shorted out until the meter is hooked up to it. So you can see how hooking these together like a chain and running an oval-shaped coil through all of them would work really well as a Tesla coil or high voltage device. Anyway, stay tuned for a test. Well, thanks for watching. Please subscribe. Remember, always be safe if you're going to do this stuff.